Mesh equations by inspection method. The mesh equations for general planar network can be returned by inspection without going through the detailed steps. Suppose we have a network like this having b number of branches and n number of nodes including the reference node. Then number of mesh equations or loop equations m equals to b minus n plus 1. For our network having n number of meshes or loops by Ohm's law, we can write Zi equals to V. Zij matrix of I of loops or mesh equals to V of loops, where I loop is equals to I1, I2 up to In. V loop equals to V1, V2 up to Vn, and Zij equals to I1, 2 up to n, and j 1, 2 up to n. The elements or entries Z11, Z12, Z1n, Z21, Z22, Z2n, here Zn1, Zn2, Znn. This is a Z matrix, where the diagonal elements are known as self-impedance and the remaining elements are known as mutual impedance. Zij equals to self-impedance if I equals to j. Zij equals to mutual impedance if I is not equals to j, and positive if the currents in I and j meshes are same, and this value is negative if the currents in I and j meshes are opposite. Now in V loop, Vn is positive if the nth loop current direction is same as source direction, else negative. Consider this network. We are having total branches of 7 and the nodes are 5. Number of meshes 7 minus 5 plus 1, that is 3. Or simply by inspection we can say that this is the mesh 1 having the current I1, and this is the mesh 2 is having the loop current of I2, and this is the mesh I3 having the current I3. That is R11, R12, R13. Since only 3 loops are there, then R21, R22, R23, and R31, R32, R33 is the impedance matrix or the resistance matrix for us. Since only resistance is present, then the currents I1, I2, I3 of the loop, which equals to the voltages V1, V2, V3, are simply R11 I1 plus R12 I2 plus R13 I3 equals to V1. Similarly, R21 I1 plus R22 I2 plus R23 I3 equals to V2. Then R31 I1 plus R32 I2 plus R33 I3 equals to V3. This is our mesh equations. So R11 is the self resistance of loop. Now if you observe in this loop consists of 1 ohm, 3 ohms and 6 ohms. Totally it is about 1 plus 3 plus 6, 10 ohms. R12 is the mutual resistance of loop 1 and 2. We need to observe the loop 1 and loop 2. This is loop 1 and this is loop 2. The common resistance is here for 1 and 2 is 3. So we are having 3 ohms. Sign, is it a positive or negative? It's going to depend upon the loop currents. So I1 is coming from top to bottom of 3, and whereas I2 is going from bottom to top of 3. So it is in opposite direction, negative sign. 3 ohms R13 is also a mutual resistance between loops 1 and 3. So between 1 and 3, mutual resistance is 6 ohms, and the direction here, the current of I1 is coming down, current of I3 is going upwards. So in reverse direction, so negative sign. Similarly, R21 is the mutual resistance between 2 and 1. So 3 again, so 3 ohms, and this is a negative since the directions are different. And R22 is the self resistance, that is I2 resistance 3, 2, 5. 3 plus 2 plus 5 is 10 ohms. R23 is a mutual one between 2 and 3, and between 2 and 3 the mutual one is 0. There is no common resistance between 2 and 3. Then R31 is the mutual one between 3 and 1, which is nothing but 6 ohms we have already seen, and this is a negative value. And R32, there is no mutual resistance between 3 and 2, so 0 ohms. And R33 is the self resistance of loop 3, that is 6 plus 4 is 10 ohms. V1 is the voltage in the loop 1, that is 10 volts, and the direction of the voltage is similar to the direction of the current. The current is going from negative to positive, so I am taking this as a positive 10 volts. Then V2 is equals to, we have voltage in loop 2. The direction of the current of V2 is in opposite since it is going from positive to negative, so it is negative opposite direction, 5 volts. And V3, it's 20 volts we have, and the direction is, the current is flowing from negative to positive, so it is a positive. Now you can try the equations by substituting these values. 10 I1 minus 3 I2 minus 6 I1 equals to 10. Equation number 1. The second equation is minus 3 I2 plus 10 I1. This third one is 0, equals to minus 5 volts. Minus 6 I1, second term is 0, and third term is plus 10 I3 equals to 20 volts. This is equation number 2. By solving these three equations, you'll get I1, I2, I3 values.